Although the last section described for us that the language we speak doesn't really influence how we perceive colors, that is, that we can still see that two similar colors are different. This section, starting on page 498, will detail for us that the language we speak can influence how quickly or how readily we are to describe two colors as different. That is, our language can cause us to view colors as different categories, as members of different categories, or as the same category, depending on how, depending on how the colors are paired with linguistic labels. So this, the first study depends critically on the fact that some languages have different names for colors of green and blue, like English does, and some languages don't. Some languages lump them together. In figure 12.9, that's on page 500, you can see that that people were given 3 shades of greenish color, and they were asked to, they were told falsely that 2 of these were very similar and one of them was unlike the others. It was the odd one out. And to please select which one was the odd one out. Actually, what was the case was these 3 swatches of color are not identical to each other, but they are the same distance apart from each other, right? So given that colors vary on dimensions of hue, brightness, and saturation, we can shift 1 unit on one of those dimensions and cause the color to become 1 unit separated from the color beside it. So A is 1 unit removed from B, and B is 1 unit removed from C in this figure. So actually, they're all the same distance from each other, but when told that one of these pictures was the odd one out, participants were more likely, if they had a word for blue and a different word for green, they were more likely to pick one of these as the odd one out than speakers who didn't have a language difference between blue and green. If they just kept them all together, then they were equally likely to pick any of the 3 chips as any of the others. So it was a distribution of about 1/3, 1/3, and 1/3. In English, people were much more likely to select the, let's see, I don't remember which one it was, but I think to select A as the green one, and that B and C were more similar to each other than A was. So that doesn't necessarily prove anything right there by itself, but we can lump with that other studies investigating color and find that there are reliable differences in how people perceive color given their language background. In Russian, there is a word that means light blue and another word that means dark blue. And because they have 2 different words to distinguish between these colors, it's not like how do I say this? So don't be confused. By calling something light blue in English, we can see that it's light blue, right? And we can see that something that's dark blue is dark blue, right? But they have a commonality of the fact that they're both in the category of blue. But in Russian, they're not categorized like that, in much the same way that we have a different word and a different category in our minds for green and for blue. These Russian individuals have a different word that means light blue and a different word that means dark blue, but as if they are entirely different categories, in the same way that we categorize green as very different from blue. They categorize light blue as very different from dark blue. That's their linguistic code categorizes them differently. So when presented with this task that we see in figure 12.10, panel B, there's a target and then there's 2 squares underneath it. If if the two squares on the bottom were both in the dark blue category or in the light blue category, I can't say these Russian words, but they're like respectively Sinny or Goluboy, something like that. Anyway, if they were either in the dark blue or the light blue category, then English speakers and Russian speakers were just as likely to were just as fast as each other. But if the square on the right and the square on the left straddled the line that was the boundary between the light blue and the dark blue in the Russian language, then the Russian speakers were faster at identifying which one of those was similar to the target, because in their minds they have a different category for the color that's light blue and the color that's dark blue. A different word of it, a different word that reflects each of those things, creates for them a different category in their mind. Whereas we might be able to distinguish light blue and dark blue the same, and as the text states, even if we were to be asked which is light blue, which is dark blue, where's the boundary, like in panel A of figure 12.10, where's the boundary between light blue and dark blue, we would pick the same spot as the Russians would pick between their words that mean light blue and dark blue. We would pick the same spot, but we don't have a different word that means each, and so we don't create in our minds a different category. So Russians are faster at performing that task than we are. In box 12.4, that begins on 512, we can see another illustration of this effect in Russian speakers. So we have different blocks here, and they're just seeing one circle at a time on the screen in front of them, and they're watching for a square. But that's not what the researchers are really interested in. The researchers couldn't care less about the square. They're just trying to give the participants something to pay attention to. But as they see one circle at a time, even before they have consciously made a response, when the color switches from light blue to dark blue, something's going on in their brain. And interestingly, that something is different than when they see a sequence of light green circles and it switches to dark green. That's like a control condition for the Russians, because they don't have a different word that means light green and dark green. We don't have a different word that means light green and dark green. We just call it light green and dark green. The Russians, too, they call it light green and dark green in their language, right? But they have a different word that means light blue and dark blue. So what's going on in their brains during the blue switching condition is different from what's going on in the green switching condition. And that's outlined in the ERP data that's still in that same box, but on page 503. You can see that the sorry, these are Greek-speaking people this time. Hang on a second. Yeah, so these are Greek speakers, but Greek and Russian have that same trait. So sorry about the confusion there, but regardless of whether they're speaking Greek or Russian, they're still differentiating between light blue and dark blue. So here in the ERP, we see that native English speakers are not differentiating between the light blue and the dark blue, or the light green and the dark green, any more than each other. But among the Greeks, they are differentiating between the light blue and the dark blue differently than they are differentiating between the light green and the dark green. So that demonstrates that they're processing in their brain the different colors, the switches between colors, differently than people who speak English. Now, there are some other studies here. I'm running out of room on my recording, so I'm gonna have to stop and talk more about these in another recording.